The overall goal of this procedure is to prepare different types of concentrations that will be used in the sessions of general engineering laboratory.
In order to prepare any type of solution, it's necessary to investigate its recipe, dangerousness, adjusted pH, sterilization procedure if it is stored in a glass or a plastic. A calculation must be done regarding the reactives and concentrations needed. In some cases, it is necessary to adjust pH and volume, labeling, and sterilize.
Some methods of sterilization are the moist heat one that it is used in the autoclave. The material introduced must be clean. It has to resist high temperatures. It eliminates bacteria and spores. In the dry heat one, we can sterilize oil, Vaseline powder, and petroleum. We can also use hydrogen peroxide. This one cannot be used in the food area. It is more applied in the pharmaceutical one. We can also use fire. For example, when we put the tip of the bacteriological loop in the fire. We can verify that a solution is well prepared by calculating its density with the volume and mass present and comparing it with the theoretical values. The consequences of an incorrect preparation of a solution can be positive or negative false, an accident with a dangerous reaction, or even no reaction at all.
Our team prepared 4 solutions. For the first one, to 7.5 milliliters of glycerol and 0.55 grams of calcium chloride was added water until a volume of 50 milliliters. A vortex was used to dissolve glycerol. For the second one, 1 gram of SDS was added to water and water was added until a volume of 10 milliliters. For the third experiment, we added 24.22 grams of trisvase to 100 milliliters of water and we put that into a hot plate and agitated it with a magnetic bar for 5 minutes, and after that we added 4 milliliters of EDTA again with a hot plate and agitating. Finally, we added 11.12 grams of boric acid. When it was dissolved, we added water until a volume of 200 milliliters. The last solution was done in an extraction booth. We added 12.5 milliliters of hydrochloric acid into 17.5 milliliters of water. All of the solutions made were labeled.
As a result, we have 4 solutions. The first one are 50 milliliters of calcium chloride, 0.1 molar, and 15% glycerol. The second one are 10 milliliters at 10% of SDS. The third one are 200 milliliters of TVA10X, prepared by trisvase 1 molar, boric acid 0.9 molar, and EDTA 0.01 molar. The fourth one are 30 milliliters of hydrochloric acid 5 molar.
There are different ways of expressing a solution concentration. The ones that are used the most compare the solute with the solvent in terms of percent mass per mass, percent mass per volume, percent volume per volume, molarity, which is in terms of number of moles of solute per liters of the solution, molality, which is in terms of number of moles of the solute per kilogram of the dissolvent, and it doesn't change with temperature in comparison with molarity or with any type of concentration that involves volume of a gas or liquid. Normality takes into account number of equivalent weight, which tell us the exact quantity of a reactive that can react with another one. The ones concentrated X times are used to keep in one container a whole stock of a solution in order to save space. Parts per million is useful when you have a very small amount of solute, like metals in a culture.
While preparing solutions, we consider the use of the correct scale to weight, analytical in this case, pour the solutions in a suitable container to stock, work with acids in the extraction booth. We do not add water to the acid. We used gloves with dangerous substances such as acids. While waiting SDS, we took care of not letting the powder fly. We used the vortex to dissolve glycerol in water because it is very viscous. To prepare a TBE buffer solution that we will need to be heated dissolved as well as the EDTA component.
It is very important to take into account some rules while making solutions for user safety and to have a correct preparation of them. Now we have different types of solutions ready to be used during the semester, like all the ones enunciated along this video. depending on the particular characteristics of the reactives involved.
Specifically, there are two hints when making a solution, adjusting pH before reaching the final boiling. There are some tools that can be used to dissolve rapidly: heat, agitation, and inversion.